Welcome. In this video, we're going to be answering this particular problem. I want you to, basically the question is, prove that there are at least 3 zeros or 3 roots, or rather solutions to this particular function right here. So how can we prove without factoring that there are at least 3 solutions to this problem? Or another way of saying this is that if we were to graph this function, how can we prove that the graph is going to cross the x, or rather the y equals 0 line at least 3 times at like these particular points? Saying that for some x value, we don't know what the x value might be, but for some x value, you're going to get a y value that's going to be 0 for this function. So let's go ahead and start answering this question. Now I'm going to be using the Intermediate Value Theorem in order to answer this, which basically says if we plug in, let me just redraw that graph actually. Basically, if we say that, let's say if we plug in an x value of something also, that this is going to say prove that there are at least 3 zeros or 3 solutions to this function within the interval, let's say the interval from -2 all the way up to +2. So we have that interval of x's to work with to prove that there are 3 solutions to this problem. Now it's very simple to answer this question actually. All you have to do is, let's say we want to plug in -2 into this function. What kind of output will we get out? So if we had an x of -2, we would get a y value, or the output, as, well, let's say -2 inside this is going to be up to the 5, then -3 to the -2, then +1. And this would actually give you an outputted value of -25. So -25, which is the main point here, is not the value itself, but the fact that it's negative. It's -25, and that's less than 0. So that'll come into more fruition, or its importance will be known a bit later. Let me just plug in more values here. So we got -2 and the y value being -25. Let's try -1. What would that give us? Well, if we put that in, I'm not going to write it out again, but you would get a value of +3. So y value, +3. Let's try 0. So 0 gives us a value of 1. Okay, let's try 1 as an x value. Well, that turns out to give us -1. Okay, let's try one more. Let's try +2. Well, that gives me 27. And now we have all the stuff we need to actually answer the problem. Now, because we have, let's say, the x value of -2, so when we use -2, we're getting a value of x that's less than 0 for this one. And this one here is going to be, like if you try x -1 in the function, we're going to get a value of y that's going to be greater than 0. So I guess I shouldn't put an x here, it should be a y. The y value is going to be less than 0 there. The y value for this one is going to be greater than 0, which means in the function, we know that around the point -2, y is going to be some value that's less than 0. And then at the point -1, it's going to be greater than 0. So it's going to be up here somewhere. And for 0, it's still positive, so it doesn't really matter that much. But if we try x1, or at the x value of 1, we get a y value of -1, which is less than 0. So the one down here, y value is less than 0 again. So we know for the positive one way over here in the graph, it's going to be back down to negative. And then for the last one, we can see that it's going to be the y value of 27 for the x value of 2. And that's greater than 0. So that's just going to be around the x value of 2. Let's say that's around here. It's going to be back up here again. And basically, the Intermediate Value Theorem says that it's going to be, because it's a continuous function, because it's the thing's a polynomial function, it's continuous everywhere. Basically, that just means the entire line here is perfect. There's no holes or anything like that. And if you have an x value at the bottom, that's like below the y, or rather the x-axis here, and you have an x or y value that's above the x-axis, there needs to be some x value that you can shove into this function to get a y value that's going to be equal to 0. Because, well, that's the logic, because it's a continuous function. And we can see that on this graph here. We have 3 visible solutions. And that is answering the question. Within the interval of x -2 and x +2, we have proven that we have at least three zeros, or 3 solutions. Some might say 3 roots to this function. And that's it. Thank you for watching. If you have any questions, feel free to ask in the comment section below. I will do my best to answer them. And I do hope you're having a fantastic day.